Okay, so let us see a few questions on inverse of a matrix. So first one is solution for the first one. Okay, here given A is equal to this, we have to find A inverse. Yes, so first of all we got to check whether this matrix will have an inverse or not. Yes, for that we have to see what is the determinant. If the determinant comes non-zero, then this matrix will be non-singular, and in that case it will have an inverse. So firstly, determinant of A, you know how to find. 1 into 4 minus 3 into 2. Okay, so you will get 4 minus 6, that would be minus 2. Clear? And this is not equal to 0. Okay, since it is not equal to 0, that means A is a non-singular, therefore A inverse exists, and your A inverse is equal to adjoint A upon determinant of A. Clear? So this is the formula to find the A inverse if your matrix A is non-singular. So clearly your matrix A is non-singular. Now we are left to find adjoint of A. So adjoint of A will be, this is 2 by 2, so very easy to find. What we have to do is just interchange the diagonal elements. So we'll get 4, 1, and you have to change the sign of these two elements. Leave at their position only. The only thing is you change the sign. So this will become minus 2, this will become minus 3. So this is the adjoint. Clear? Next, your A inverse will be adjoint of A upon determinant of A. So straight I write this. So you'll get 4 minus 2 minus 3 1 upon minus 2. Okay, so this would imply we can since it is in denominator, that means this will divide each element. So you will get 4 divided by minus 2 will be minus 2, this will be 1, this will be 3 by 2, this will be minus 1 by 2. Okay, so this is the required inverse. Okay, so this is the inverse of A. So now let us move on to next question. So for the next question we have to follow the same procedure. Firstly we got to find the determinant. Okay, and if the determinant comes non-zero, then the matrix will have an inverse, otherwise no inverse. Okay, so solution, this is for 2. Okay, given A is this 1 3 3 1 4 3 1 3 4. So this is your matrix. You have to find A inverse. So this matrix A will have inverse only if determinant of A is not equal to 0. Okay, so let us find the determinant. Now determinant of this, I will expand along the first row. Okay, so recall that you got to follow this pattern. Yes, so I am doing along the first row. So what we have to do, we have to copy the sign first. Here is plus, so no need to write that. Then we'll copy this element of that first row. Then we'll write the we'll cover this column, we'll cover this row, and the remaining we'll write in determinant form. Okay, then we'll write down that sign, okay, because we are doing along the first row. Okay, so minus, then we'll copy the element 3, then cover this second column, cover this row, then you are left with 1 3 1 4. Okay, then that sign will come plus. Okay, then copy this 3, then cover this first row and this column, then you are left with 1 4 1 3. Now you know how to solve. So 1, and in bracket 4 4s are 16 minus 9 minus 3, 1 into 4 4 minus 3 plus 1 into 3 3 minus 4. Okay, now 16 minus 9 will be 7, so 1 into 7 7, then 4 minus 1 1, so minus 3 into 1 minus 3, then here 3 minus 4 minus 1 into 3, so minus 3, you will get 7 minus 6, that is equal to 1. Clearly this is not equal to 0. Okay, therefore A inverse exists and your A inverse is given as adjoint of A upon determinant of A. Okay, so we got to use this formula now because the given matrix is non-similar, so obviously there would be unique inverse for this. Now we got to find adjoint of A. So let us find the adjoint of A. So you know that if your matrix is given as this, if your matrix is given as this, then adjoint of this matrix is where A11, A12, these denote cofactors of these elements respectively. Okay, transpose. Done. So if you have a matrix, then this is how we give the write the adjoint. Clear? So let us find the adjoint of this. So adjoint of this will be, the best way to write is firstly what you do is, in order to find the adjoint also you got to remember this. Okay, this pattern you have to remember: plus minus plus minus plus minus plus minus plus. Okay, this will be helpful. So what you can do is, how many elements are there? 9 elements. So we'll make 9 this, we'll make these parallel lines. Okay, there will be 9. Actually I'm trying to write the determinant. Okay, but at present right now I'm leaving it blank. Okay, so you have to make 9 like this. Later we'll see this would make your work easy. What to say, it will be more easy to find the adjoint if you follow this method. Okay, so you should make this first. Okay, then follow this pattern and then put the sign. So here plus, so no need to write. Here minus, minus, plus, no need to write. Okay, then minus, then plus, no need to write, then put minus over here, plus, no need, put minus over here, plus, no need to write over here. Now what you do is come to this. Okay, 1, cover this column, cover this row. What you are left with? 4 3 3 4, right over here. Sorry, 4 3 3 4. Done. Now come to the next 3. So you got to cover this column, second column, and the first row. You are left with 1 3 1 4. So 1 3 1 4. Done. Then come to the third element. Okay, cover this column, cover this row. You are left with 1 4 1 3. Right. 1 4 1 3. Done. Now next you come to this. Okay, so in this case you have to cover this row, this column. You are left with 3 3 3 4. Then come to 4. Okay, cover this row, cover this column. You are left with 1 3 1 4. Okay, next we come to this element 3. Cover this third column, cover this second row. So you get 1 3 1 3. Okay, now come to this. Okay, so we got to cover the third row, first column. You are left with 3 3 4 3. Okay, then come to this element. Okay, cover this column, cover this row. You are left with 1 3 1 3. Okay, next come to this element, cover this third row, cover this. Then you are left with 1 3 1 4. Done. Now find the determinant. Okay, so 4 4 is 16. 16 minus 9, it would be 7. Yes, then 1 into 4, 4 4 minus 3 will be 1, so we'll get minus 1. Okay, then 3 minus 4, that would be minus 1. Okay, then 3 4 is 12. 12 minus 9 will be 3, so it will become minus 3. Then 4 minus 3, 1. Okay, 3 minus 3 will be 0. Okay, here 9 minus 12 means minus 3. Here 3 minus 3, 0. 4 minus 3, 1. Okay, and transpose over here. Don't forget to write the transpose. Okay, now transpose of this matrix means interchange the rows and columns. So 7 minus 1 minus 1 minus 3 1 0 minus 3 0 1. So here what happens? First column becomes first row. Okay, so on. Okay, so you got the adjoint also. Now let us find the inverse. Okay, so inverse is given as this. Yes, so now we know adjoint and we know the determinant. Yes, so let us put the values. So here your adjoint is 7 minus 3 minus 3 minus 1 1 0 0 minus 1 0 1. Okay, upon determinant was 1 for this matrix. Yes, so 1 over here. So each element is divided by 1. Again you get the same thing. Okay, 7 minus 1 1 0 minus 1 0 1. Okay, so this is how we find the inverse of 3 by 3 matrix. Okay, so in this video we covered how to find the inverse of 2 by 2 as well as 3 by 3. Okay.